With the so-called geoengineering approach, the climate could theoretically be influenced and cooled artificially. The Bernese researchers are now investigating whether it is possible to prevent the melting of the West Antarctic ice sheet by artificially dimming the sun. The results show that the anthropogenic effect does not work without decarbonization and carries a high risk. Are there any urgent solutions that can stop climate change? Engineering methods of artificially affecting climate have been discussed for some time under the term geoengineering. However, the majority of climatologists criticize them. High risk, unpredictable consequences for future generations. Avoiding a key climate tipping point. The window of opportunity to limit the global temperature increase to below 2 degrees is closing fast, says ice modeling specialist Johannes Sutter, so it is possible that technical measures to influence the climate will be seriously considered in the future. That is why, he says, it is necessary to use theoretical models to study the effects and risks of solar radiation management. Solar radiation management, SRM, is a term used to describe various methods of blocking solar radiation in order to make the Earth cooler. A key reason for the increased interest in geoengineering is the avoidance of tipping points at which the climate could change abruptly and irreversibly. These include the melting of the West Antarctic and Greenland ice sheets and the associated meter-high sea level rise. Observations of ice flows in West Antarctica indicate that we are very close to a so-called tipping point or have already passed it, explains Johannes Sutter. With our study, we therefore wanted to find out whether a collapse of the ice sheet could theoretically be prevented with solar radiation management. Artificially dimming the sun. Specifically, Sutter and his colleagues have investigated what would happen if so-called aerosols, suspended particles in a gas, introduced into the stratosphere succeeded in blocking solar radiation from the Earth, a dimming of the sun, so to speak. So far, research has focused on the global effects of solar radiation management, SRM. Bern's study is the first to use ice model simulations to show the impact of such a measure on the Antarctic ice sheet. The study looks at the ice sheet's ability to evolve under different greenhouse gas scenarios in the future and produces distinct results. If emissions continue unabated and SRM occurs by mid-century, the collapse of the West Antarctic ice sheet could be delayed somewhat, but cannot be prevented. In the medium emission scenario, the SRM deployed by mid-century could prove to be an effective tool to slow or even prevent the collapse of the ice sheets.